Okay, now we're going to solve some exponential and logarithmic equations. Number 56, solve for x. 4 to the x plus 3 power equals 32 to the x minus 1 power. All right, so this one, what you want to notice whenever it's true is if your bases can be written as a power of the same number. So hopefully you notice that 4 is 2 squared and 32 is 2 to the 5th power. That will make life a lot easier if you can notice something like that. So this is 2 squared to the x plus 3, and then a power to a power you multiply. So you'll distribute that 2 and get 2 to the 2x plus 6 power. And then here, this 2 to the 5th is to the x minus 1 power. So here we're going to distribute as well. And we've got 2 to the 5x minus 5 power. So when you have the same base, and these are equal, then the powers have to be equal. So 2x plus 6 has to be equal to 5x minus 5. Right, so power to a power you multiply, distribute when you have a quantity. Power to our power, multiply and distribute. Same base, set the powers equal. Now we can just solve for x by getting all your x's on one side and all your numbers on the other. Here what I just did was I subtracted 2x from both sides, right, to get that 3x, and then I added 5 to both sides to get that to cancel off to get all my x's on one side and all my numbers on the other. And then you can divide by 3, and x is 11/3. Number 57. Number 57 says solve for x. 3 to the 2x plus 1 equals 7 to the x. All right, those you can't write as the same base. So in this case, you just have to take the log of both sides, and I'll just use base 10. You either want to use base 10 or base e, one of the logs that's on your calculator. Take the log of that, and that's equal to the log of that. Then you can use that property of logs that says you can bring that power out in front. So we've got the quantity 2x plus 1 times log of 3. Equals, bring that x out in front, x times log of 7. All right, then here's where you want to realize that log of 3 and log of 7 are just numbers, kind of like square root of 3 and square root of 7 that you could approximate on your calculator. But we want to keep this in exact form as long as possible. So we're just going to distribute the log of 3, 2x log of 3 plus log of 3 on the left side, and then x log of 7 is on the right side. All right, so then just like any other linear equation where all you have are x to the first and numbers, you want to get all your x's together. So I'm going to keep this 2x log of 3 on one side, and I'm going to subtract off that x log of 7. So that's going to be minus x log of 7. Basically subtracting it from both sides so that it comes over here. And then I'm going to do the same thing with this log of 3 that doesn't have an x. That's just a number, so we want that to go over to the other side. So that's going to be a negative log of 3 over here, subtracting log of 3 from both sides. All right, then these two things that both have an x in it, we can factor x out of. So x times the quantity 2 log 3 is left when you factor x out of that term, minus log 7. And that's equal to negative log 3, and we're almost done. Now we just want to divide both sides by what's in parentheses here, this 2 log 3 minus log 7. Divide both sides by that, parentheses 2 log 3 minus log 7. And that cancels. And that's what x is equal to. So this is your answer. It's not the prettiest answer, but it is exact, which is nice. It can be simplified or condensed a little bit because you can use some properties of logs. 2 log 3 is the same thing as log of 3 squared or log of 9. And when you subtract 2 logs, you can write it as log of the quotient. So log of 9 minus log of 7 is log of 9/7. So that's a little bit more condensed. There's not much more you can do than that. And then to get a decimal, you can type either one into the calculator and you should come out the same for both. So for example, the first version I had was negative log of 3 over the quantity. You gotta be careful and put parentheses. 2 log of 3 minus log of 7. All right, of course that's the same thing as negative log of 3 divided by log of 9/7 using properties of logs. So approximate decimal is negative 4.371. And then you can just round to however many decimal places are requested. Number 58 is solving for x with an exponential that involves e. So for that one, we'll probably use ln to undo the exponential base e. So 2e to the x minus 1 plus 5 equals 17. The difference with this one is that we have to first isolate this exponential. You've got to get that exponential all by itself before you can undo it. So you've got to subtract 5 from both sides to get 2e to the x minus 1 equals 12, and make sure you divide by any coefficient that's there. So e to the x minus 1 equals 6. Then you can take ln of both sides. Ln of that equals, let me move this over, ln of 6, because ln is log base e, and log base e of e to some power just gives you that power. They undo each other. Log base e of the exponential base e. So x minus 1 equals ln of 6, and then x is just ln of 6 plus 1. So again, there's your exact answer, kind of like square root of 6 plus 1, that you can then approximate with the calculator by typing in ln of 6, close the parenthesis, plus 1. 2.792 rounded to 3 decimal places. For an approximation. All right, for a logarithmic equation, we want to undo the logarithm, but you want to make sure that the logarithm is by itself, which it is in number 59. Log base 4 of x plus 3 equals 2. So we can go straight to undoing it, and there's 2 ways you can think of it, either as rewriting, the base is 4, the power is 2, and that's equal to x plus 3. Or you can think of it in terms of, you can think of it in terms of undoing the logarithm by exponentiating with base 4. If you exponentiate both sides, 4 to the cancels out the log base 4 of, and then 4 squared is 16. So 16 is equal to the x plus 3. Subtract 3 from both sides, and x is 13. And then logarithms just have the extra step that you have to check because you can't take a log of a negative number. So you always want to check your solution or solutions to make sure that it doesn't involve taking a log of a negative number. Of course, with 13, we're fine here. Number 60, we've got, come back. Oh, there we go. Number 60 is a sum of logs that we're going to have to combine before we can undo. It says log base 2 of x plus log base 2 of x plus 4 equals 5. All right, so we can't do anything with those logarithms the way they are. We need to combine the sum of two logs using that property of logarithms that says we can combine those to log of the product. All right, so that you have a single logarithm equal to a number. Then you can undo the logarithm. Here you would either exponentiate both sides. The base is 2, so you can raise both sides to the power of 2. And then that will cancel that out. So x times x plus 4 equals 2 to the 5th. Notice that would be the same thing as rewriting. The base is 2, the power is 5, it's equal to that product. So then we distribute x squared plus 4x equals 32. Set it equal to 0 because it's a quadratic. Somebody's alarm's going off. And factor x and x. Two numbers that multiply to give you negative 32 are going to have to be positive and negative. So we want their difference to be 4. 16 and 2, 8 and 4. 8 and 4, and we want the bigger number to be positive so that the difference is positive. So x equals negative 8 or x equals positive 4. But here, remember I said you've got to make sure you are not taking the log of a negative. Log of negative 8 up here is undefined. Log of negative 8 plus 4 would be undefined. So that's not a solution. That's a solution to this quadratic, but not to the original equation. Whereas x equals 4 is fine. So that's your solution.